This is a neuron. A neuron is made up of four major components: the dendrites, which receive information from other nerves, the cell body or cell membrane, which processes and gathers information, the axon, which carries information to the axon terminal, and the axon terminal, which passes on information to the next nerve. Action potentials. An action potential is when a nerve is stimulated and there's a change in the membrane's potential, which is the difference in charge between the inside and outside of a cell. When a membrane's potential is at rest, there is more sodium outside of the cell and more potassium inside. The outside of the cell is more positively charged. At-rest membrane potential is equal to negative 70 millivolts. This means inside of the cell is 70 millivolts less positive than the outside. At rest, all channels are closed. When a nerve is stimulated, it reaches threshold potential, which is equal to minus 55 millivolts. The inside is now 55 millivolts less positive than the outside, meaning the outside of the membrane is becoming more negative. The sodium channel is now open, and sodium rushes into the cell to make it less negative. When the inside of the cell reaches 0 millivolts, it is called depolarization. Once the inside of the membrane goes beyond 0 millivolts and up to 30, it is called overshoot. This means that the sodium pump will close. The change in the membrane potential causes the potassium channel to open. It's important to note that the potassium channel closes and opens slower than the sodium pump. Potassium leaves the membrane, making it more negative. This causes the millivoltage to go back into the negatives. This is called repolarization. As we noted earlier, the potassium channel is slower to open and close. This causes the millivoltage inside the cell to go beyond being minus 70 millivolts. Hyperpolarization causes the sodium-potassium pump to open. Using ATP, it brings 3 sodium ions outside the membrane and 2 potassium ions inside. This is a synapse. A synapse is the connection between nerves. Synapses are made up of 3 components: the presynaptic cell membrane, the synaptic cleft, which is the space between the 2 synaptic membranes, and the postsynaptic cell membrane. Action potentials originate from the presynaptic cell and allow for the communication of nerves. When the action potential reaches the presynaptic cell membrane, it causes the voltage-gated channels to open, allowing calcium ions into the cell. The release of calcium allows vesicles to bind with the presynaptic membrane and be released from their vesicles into the synaptic cleft. Neurotransmitters bind to the receptors of the postsynaptic cell membrane, which opens the protein channels, allowing ions to flow in and out of the cell. When positive ions flow into the cell, it'll cause depolarization of the postsynaptic membrane, meaning an action potential will occur. If negative ions flow into the cell, it causes the membrane to be less excited, not allowing for an action potential to occur. Neurotransmitters only temporarily bind to the postsynaptic membrane receptors. The first thing that can happen is diffusion. Some neurotransmitters are diffused away from the receptors until they are no longer at a reachable distance. The second thing that can happen is the neurotransmitters will be enzymatically degraded. What this means is that the neurotransmitters will be broken down by an enzyme that specifically targets them. The broken down parts of the neurotransmitter are then recycled or diffused. The third thing that can happen is that the neurotransmitters are recycled. They are brought back into the presynaptic cell through neurotransmitter transport proteins. They are then repackaged and re-released into the synaptic cleft.